got about 10 minutes here, but this will work. So here's what's different about the 102 summaries versus 101. So again, you're going to do some research. You're going to read the paper that's assigned, but you're also going to go find a second paper. So instead of just citing one paper, you'll cite two. You will critically read the document. You're also going to discuss this. So after you write your summary, you post it online. If you know, and it's only 300 plus words, and you know, don't shoot for the minimum. You know, when you're writing in your first stab, just let it flow. Just, you know, put the ideas. One thing I find when I'm writing, my brain is typically working a lot faster than my fingers. So if the new thought comes, rather than like suppressing it, write it. You know, just get even one line, put a return, then come back to it. You know, put one little hook there so you can come back to it and finish it off later. When you post your summary, you're going to post it twice. Once to the forum, and you'll do some peer review, and that's what happens in all academic settings. When I want to publish a paper, a bunch of other people have to shoot holes in it first, and then it's, you know, finally published. So, you know, take some time, do some peer review on that, and then you'll upload it again for grading. Kind of a 3-paragraph minimum. Do start with a catchy title. You know, write some kind of title that, you know, grabs your reader, and a lot of you did a really good job with that. You know, maybe take a stab at it, but then, you know, sleep on it, and then something will pop out the next day, and you'll put a neat title on that. When you submit it, put your last name in there, put your first initials fine, and then 102, and then summary 1. You'll have 5 total, so summary 1, 2, 3, 4, 5. Nice job last semester. I saw, you know, very few spelling errors. Microsoft takes care of that. The grammar was good. Punctuation, you know, quite good. So for me, it's much more of a pleasure to read if I can just focus on the ideas rather than that kind of stuff. Put a good transition in between the paragraphs. Read it out loud to, you know, to a friend before you put it in there, just to make sure it reads clearly. You also need to put in at least one equation. In the Tuesday's lecture, we actually looked at a little bit of equation formatting. I typed out, I showed you how to make the ADA in Microsoft Word. You don't have to use the equation editor. You can just use normal symbols. There's nothing that's going to be that crazy. When you cite something, cite it like this is the Harvard style, with first author's last name and then the year. Or if you're using the author's name in a sentence, then you just put the year. Okay, so that's pretty clear. This is the equation I was mentioning from Solomon. So when we were talking about the laws of thermodynamics on Tuesday, we talked about force, we talked about power, and we talked about energy. This is temperature, and as it turns out in this Solomon equation, this is the F is the solar forcing power. And let's see, if humanity is running at 16 terawatts, and actually we can just do that really quick. If humanity is running at 16 terawatts, that's 16, somebody write this down for me, 16 times 10 to the 12th. So what's 16 times 10 to the 12th times 10 to the 4th? 16 times 10 to the 16th. So that's 160 times 10 to the 15th. It's 160 petawatts is the, I don't know how, somehow I just did that in my head, but 150 petawatts is the amount of power that's hitting the planet right now from the sun. That is F. That's F. Now, this little delta T here is the change in the average temperature of the atmosphere. So obviously, there are as many temperatures in the atmosphere as you like, because it's different everywhere and it's changing all the time. But you could sum up all of the temperatures on a volumetric basis and come up with some average. and we're getting better and better at that all the time. The delta T is the change in the temperature of the atmosphere. And you can do it in Kelvin, you can do it in Celsius, Fahrenheit, it doesn't matter. So this guy though, N, is the net forcing effect of humanity. And so, in my mind, so is global warming real? Is climate change a hoax? Well, if you get back to just logic, humanity is either making the world warmer, colder, or neither. So you got to take your pick, and you might, and there are some neat figures in the book we'll get to later, but you can see that some of our activities actually have a cooling effect, but it appears on average by putting greenhouse gases in the atmosphere, the net effect is positive. So that's what N is. It's the net effect.
Not to mention we're warm-blooded. So.
We are warm-blooded, and we are living far from thermodynamic equilibrium. Until your heart stops beating, you're always living, from thermodynamic. Okay, so as it turns out, though, when I mentioned the first and second laws last time, see that lambda I talked about? That lambda actually has units and dimensions of entropy. And that's something that's fascinated me a little bit. And if you read that 101 paper, you look at the relationship between, entropization of the atmosphere. So, okay. So that's how to put an equation in your summary. And I also put it in as if you would just read it. So anthropogenic radiation forcing governed by N equals F minus lambda delta T, where F is the added energy due to anthropogenic radiative forcing, N is the net heat flow, and lambda delta T is the energy radiated to space by a warmer Earth. So I could read that equation as part of a sentence, and you know what each of the variables are. You don't have to go looking and finding. It's all right there. So that's how to do the equation in the sentence. So that's new to Energy 102. Okay, let me see if I can find the paper. Okay, great. So here's Solomon, and so since 102 is cross-listed between energy and climate change, I thought I would start 102 with a climate change paper. There's a lot here. It's thick, but just as I try to do with my lectures, we can just kind of get straight to the pictures. So this is showing surface warming, and this degrees C, that is the delta T. That's all that is. That from here to here is delta T. What this paper is pretending like is like, let's just imagine or pretend in 2050, no more combustion. I mentioned, remember Amory Lovins I talked about reinventing fire? So in Amory Lovins' world, by the year 2050, we don't have to burn anything. We have reinvented fire. Well, what happens? Well, CO2, until someone invents the artificial tree or some machine that actually sucks CO2 out of the atmosphere in the absence of sunlight or with sunlight, what have you, it stays around. Just there's a lot of it. 400 ppm kicking around. So this is the sort of the natural predicted decay of CO2 in the atmosphere, as well as N2O, as well as methane. And I don't know all of the molecular mechanisms for breaking these guys down, but that's what it looks like. Yes?
So those projections, that's 22, that was 2050, by 2100 on this left chart here, the surface warming,
Mm-hmm.
that's as high as the temperature of the atmosphere will get. And that's, they projected that?
Those are the models. Those are the models.
So those resources will be used, and the temperature of the planet will get to that.
That's the model. Yeah, that's the model.
There's no change. There's no climate change.
Who knows? Somebody could come up with some fantastic invention that just sucks all the CO2 right out of the atmosphere as fast as we can make it. ExxonMobil's trying. They just had a ad saying carbon capture is their new thing, and had a lot of bright engineers, smiling, saying we do it.
Scandinavia is building bricks. Did you hear about that?
Mm-mm.
They've taken carbon out of the atmosphere and turned it into.
Oh, maybe I did hear a little bit of that. Okay.
Yeah.
Yeah.
It can be used as a building material.
So, but obviously to break that CO2 bond, you have to put the energy has to come from
Yes,
somewhere.
sir.
Right. Okay. We'll talk a little bit more about this because it's 12:20. I want to wrap up, but I've underlined a few things because I wanted to get into some of the physics of global warming, and we will talk about when we do passive solar. We'll talk about the full spectrum of the sun and why different molecular species are opaque to different wavelengths, and that's where the greenhouse effect comes from. You do not need to know calculus to take this course, but as you can see, I do want you to be familiar with that first equation. If you want to kind of dig through the calculus, great, but that's where it all comes from. Okay, I'll see y'all Tuesday. Thanks a lot.
Are you gonna go?
Actually,